This is a presentation we've given quite a few times throughout Australia over the last 3 or 4 months. And it's got a lot of resonance with the people we've been delivering it to because it's actually stuff we're doing for real. So it's not just theory, it's stuff we can point to concrete examples of our clients doing this. And where our clients have been deploying what we're about to talk about today, they've noticed some real measurable benefits. It's been really effective, and we're very proud to have been involved with this. So just very, very briefly, we're a technology consulting firm. We've been around for over 20 years. We do work throughout all of Australia. We've had quite a bit of work in New Zealand this year. We do work throughout Asia and the Middle East. So even though we're very much an Australian company, we've got a surprisingly large footprint. And there's a few things that we focus on. So we're not a huge company. We're not a big global multinational. We're quite niche and boutique in our own way. So we've got a management consulting business that focuses on process improvement, process architecture. And then we use Red Hat technologies in the area of things like process automation, integration, APIs, more often than not on an OpenShift platform. And we're also partners with a number of Red Hat partners, Intando and Tricitec. Now I'll come back to those a little later in the presentation. But we were the first company in the world to be a partner of all three of those organisations. And watching those three work together, I think that we're actually also quite proud to have made that leap earlier than most as to how we can use these partnering technologies very well together. So today's talk is largely about microservices. Now, I don't really want to get into the debate of what a microservice is or isn't, because you can read all sorts of blog posts where people argue to the death about what is and isn't a microservice. Instead, I'd rather focus on the benefits of microservices and talk about a particular pattern that we've been using to implement those microservices to be able to deliver change to our clients in a very rapid way. So in terms of the benefits that we're able to get from what we're talking about today, the ability to deliver superior user and customer experiences. So whether you're a government organisation, whether you're a bank, you're an airline, everyone seems to be talking about maximising the customer experience, whether it's their external customers or their internal customers. So for example, if we had a monolithic application that does most things for our customers really well, but there's one thing it doesn't do particularly well, the little red, angry, non-smiling face there, then a monolithic application might not be able to support something that our customers would consider to be a holistically good customer experience. Individual touch points might be good, certain might be negative. So digital business is something that our clients are also very interested in. We've heard the word or the phrase digital transformation used dozens and dozens and dozens of times over the course of the last day, because it is simply a business imperative. If we're going to, especially as a commercial organisation, languish in the analogue world, we're not going to deliver the types of products or services that our clients expect us to. So by adopting a microservices approach, we can continuously improve what we're doing. It enables us the ability to evaluate new ideas, and we heard people talk today about whether it takes 9 months or potentially even 18 months in the case of the Heritage Bank CIO's example to roll out new software. Then our ability to prototype, as the gentleman from Deloitte talked about earlier, and to evaluate new ideas is severely impaired. And likewise, adapting to meet new demand. So in terms of responding quickly to business and market change, if we've got these monolith applications that we've got to do all this regression testing, and we might have to take it down before we can deploy, our time to benefit is going to be much longer than we'd like. So by taking a microservices-based approach, we can actually increment change in slices, because on the left-hand side of that model, you can do agile development, but you can't necessarily do agile deployment, which is basically the same thing as continuous delivery. So being able to break our problems into chunks and solve those chunks incrementally means that we are benefiting much, much sooner. And if we're, say, improving a customer experience, our customers are going to notice it quicker. If I work for a bank and one of my competitors introduces a new product that takes me 9 months to respond, that's generally not going to be as effective if I can respond in a matter of weeks, if not a month, say. And one of the reasons it's hard to rapidly adapt to market change is that cost of time and deployment. So I'll talk a little bit later about a real example we've been working on with a client where they've got a very heavily customised legacy monolith application. And it's so heavily customised that if they want to make any changes to that to add functionality, they actually have to get board approval to do it, because it's considered such a risk to touch this thing. So when we've got these long regression testing and deployment cycles, we actually end up with a model that looks more like this. So we've spoken to a number of our clients who say, actually, our ability to design and develop a change is relatively good, but it takes us so long to go through the regression testing and deployment that we end up spending 80% of the time on those relatively non-value-adding activities as opposed to design and development. So again, by taking a microservices-based approach, and we can get these things in quicker, chunk at a chunk, rather than doing 20 changes in one go, the business, the clients are going to notice the change quicker. And there's one thing almost all of the CIOs we speak to say, is that the business complains that IT is unresponsive. So IT does what it can, but the business goes out, spends its own money, does shadow IT type investments that IT then can't control, security implications, et cetera, et cetera, et cetera. So there's the Gartner model that we quite often use as well, where Gartner distinguishes between the so-called system of record, system of differentiation, which means doing things differently, or the system of innovation, which means doing different things. Now, Gartner also points out with that red curve there that if you're trying to differentiate or if you're trying to innovate, unless you're doing that quickly, you're not really going to differentiate or innovate because someone else is going to beat you to it. So a system of record is more often than not going to be some sort of monolithic, packaged or out-of-the-box application. It typically won't support what you want to do in terms of differentiation or innovation, because if it was in a packaged application that anyone can buy off the shelf, it's very unlikely, therefore, to be differentiating or innovating. It's almost a truism. So what we do at Leonardo is we focus in that little red box only. So we don't do packaged application stuff. What we do is we adopt what we call basically a platform of a number of different components, most of which come from Red Hat, to be able to very quickly develop these so-called systems of innovation and systems of differentiation. So whether it's business process management or business rules automation, whether it's microservices or APIs, what we've done is come up with an approach, both in terms of the technology stack and in terms of the methods for getting it designed, developed, tested and deployed, that means that we're able to very rapidly develop solutions to clients' problems, A, because we're taking small chunks at a time, like this, rather than trying to develop 10 changes in one go. And what we've discovered is this works really well. So I'm going to talk a bit more about the technology architecture and how we make some of these things happen. So we typically see two major use cases. There's either a monolithic custom application that's become far too hard to maintain. So one of our clients, for instance, has a website that's available to the public to use, and if they change a business rule, they have to get a JavaScript developer in. The JavaScript developer then writes a whole bunch of code. The website has to be taken down for half a day and put back up again. And the second use case is augmenting the monolith packaged application, or in some cases actually removing that functionality from the monolith so that it can be upgraded, so you don't go through this 9 months just to upgrade and maintain supported. So microservices, Netflix is the poster child for microservices because they went from being a blockbuster type organization that actually would ship you a DVD to being someone that just shipped you digital content over TCP/IP. And what they discovered is the architecture they had was totally unsupportable once they started to actually really succeed and grow. So they rewrote everything in microservices. Now, this typically won't apply to all of us because there are a whole bunch of situations in which we can buy an HR system off the shelf. We can buy a financial accounting system off the shelf. Writing those from scratch in microservices would be madness. But it probably arguably is equally as mad to try and add a whole bunch of functionality to those out-of-the-box applications that doesn't have to be in it. So all I'm going to say about microservices, to not buy into the what are they argument, is that they're independently deployable, they're by definition not monolithic, and perhaps almost equally as importantly, they can be called from other code in a non-language specific way. So it doesn't matter if I've got some .NET running in a VM here, or I've got some JavaScript running in an OpenShift container here. By using technology-independent messaging, they can talk to each other happily. So there's two scenarios that our clients come to us and say. They say either we want to digitize our processes and become a digital business, or they come to us and say we want to adopt a microservices architecture. Now, there's a pattern that we use that actually means that we can use the same pattern to address both of these use cases. And sometimes we end up with a situation we've developed some code and we don't know whether it's processes supported by microservices or microservices supported by processes, and nor does it really matter. So if you think of a BPMN model, for those familiar with business process model and notation, it's a graphical way of designing a process that can actually, as a version 2 of that standard, be executed. So what we can do is we can look at a traditional sort of process model like this, where you might have a business user sent a particular task to do, a human task, which is either a manual or a user task if you're a BPMN person. Now, a person, is that always going to be the best way to do it? So, for example, one of our clients said to us last year they wanted an onboarding application, and they wanted us to send information to a certain HR person so they could type it into the HR system. And we said, well, we've got the information, the HR system has an API, why don't we just send it to the API and cut the person out of the loop? So that's the second type of task there. If we can cut the person out effectively, great. And in some cases they say to us, okay, yes, that application we need to type the information into doesn't have an API. So our response to that is, well, we can use robotic process automation and send it to its API. So in other words, this is not just process automation, we might be calling microservices to do some of these things, but the concern that the chief architects and CIOs we talk to have about microservices are diagrams just like that one there, where it's quintessential spaghetti. That's complexity. And so they say to us, well, I'm a bit nervous about how we manage this complexity. I walked into one of the banks a few years ago and got handed a diagram like that, and I had a look at it and said, how long is it going to take me to understand this diagram? And the guy who gave it to me said, oh, in about a year you should get it. And I said, I've got to go live in 7 weeks. So being able to reduce complexity and actually show the microservices being orchestrated by BPMN process, for instance, means that a business person can understand this. So for example, in the Red Hat Process Automation Manager, there's a task called a REST task, which basically means call a RESTful API and pass this data object to it. So that means I can have a nice little graphical diagram with all my normal business logic, my decision gateways, etc. And I can use that to orchestrate my various microservices in a way that's very easy to understand, not just for an IT person, but potentially even for a business person. If we take that one step further, so there's, as well as Red Hat Process Automation Manager, there's Red Hat Decision Manager for business rule automation or automating business decisions. So what we can actually do then is have an even more sort of sophisticated microservices architecture or process digitization method, where we're calling these external APIs that represent a microservice or maybe another system, and we're also using business rules to help automate the process. So between the microservice, the REST calls, and the microservices themselves, we've actually got a way of breaking up our functionality into increasingly small components. So for example, using this model, if I want to change an underlying business rule, there's a whole bunch of other things that don't need to know that's changed, and I can go through my automated regression testing and find out whether in fact I'm still getting the desired result. So here's one particular sort of way we could do this. So we've got, in this case, a system of record. There might be some microservices that it uses, but in this case we would have that talking to the Red Hat Process Automation Manager to orchestrate either those microservices, make calls to other business applications, to Robotic Business Process Automation API, and also calling Red Hat Decision Manager to pass, again, data down there to the business rules. And in some cases, we do that in straight-through processing. So we might have a system of record that manages all the user interface. And we might just do straight-through processing where everything in Red Hat Process Automation Manager and Decision Manager is done under the hood, and it simply passes the message back. And I'll talk about a concrete example of that soon. We might have examples as well where we want to surface user tasks that require human input. So it might be, for argument's sakes, someone processing a bank loan application. And you might have a number of loan applications that the business rules say these meet all the criteria in terms of risk, so let's automatically approve it. Or there might be some where we say we want a human to review this, and that's when Tando comes into the piece. So if you've used, whether it was the Red Hat Business Process Management Server or the recently renamed Process Automation Manager, you'll be aware that you could use forms to build little user interfaces, but they were ugly, lacking in functionality, and something that users absolutely hated. So I think Red Hat decided that rather than go and redevelop that capability within the tool, they would partner to do it. So Intendo is a company originally formed in Italy that's now based in San Diego, and they have what's called a digital experience platform, which is a fancy way of saying you can build websites, web applications, or what they call modern applications to surface information or tasks to a human. And so that's actually now bundled with the Red Hat Process Automation Manager. You can get a limited use license for using with Red Hat Process Automation Manager, but perhaps more importantly, they're actually pre-integrated. So there's some things called plugins that talk to the Red Hat Process Automation Manager API, and that might, for instance, bring back a list of currently running processes. And then there's things called widgets, which are UI things you plug into the user interface that then talk to the plugins. So that would be how I display my list of currently active processes. So let me go on to talk about a real-world example. So there's a government insurer that processes 2 million claims a year. And traditionally, all 2 million of these claims were processed by a human. A human would read it, a human would decide yay or nay, and there was relatively little automation. So when a new government came in, the minister responsible decided that it was time for this organisation to get with the modern world. And so they decided they would invest in what they thought at the time would be business rule technology. So you could receive a message from the claims management system, the heavily customised claims management system they struggle to upgrade and which is risking going out of support, and instead pass it to a business rules engine. And what they were planning to do was write essentially a monolithic Java application with the business rules engine embedded inside. And we said, okay, that will work, but there's probably a better way. So what we suggested was they develop a number of essentially processes that themselves are microservices that called other microservices, and that microservice might, for argument's sake, pull some information back from their data warehouse. There was a statistical model they had that said if, for example, the word sunburn occurs in the description written by the doctor, odds are there's a good risk it's not a genuine accident, be it sports injury, car accident, work accident, and therefore wouldn't be covered by the legislation and wouldn't be paid. So rather than do that, we said, let's just split everything up into its component parts. And that's what we did. So we wrote, in the end, 3 small processes that were microservices. They called quite a few business rules underneath them. And there was about a dozen or so microservices, all written in Node.js, that performed a variety of different functions that we could have done with an inside Process Automation Manager, but we concluded that A, they'd be more reusable if they were Node.js microservices just called through a RESTful API by passing a JSON package. And we also concluded it would actually be quicker. So in other words, when we were moving to this microservices approach, we didn't want to say what we did in the Process Automation Manager become a monolith all on its own. So we split down everything into the components that we thought would maximize reuse and would enable us to change one component without necessarily having to go and regression test the entire stack. So here's a very simple example. There's nothing confidential I'm giving away here. If you can't read the text in the boxes, that doesn't really matter. So each of these blue tasks here represents a REST task. So for example, that task is historical data, which means a call to a microservice which calls the data warehouse to give us the injury claimant's history. Here we're going off and saying, here's a bunch of diagnosis codes that were provided by the doctor, and here's basically a block of text that was the long text description. I'm going to give this to something else so it can give me a list of words back that are statistically relevant. And then, oops, wrong one. And then we've got a bunch of business rules. So for example, how is the client managed? So it might be that the client is someone who has made threats to the organisation before, and we're going to send them off to be dealt with a special central branch. And then there's a whole bunch of things here where we pass a data object in, then we get it out, and we pass the output to the next rule as input. Then the output of that gets passed to the next rule. So we move through a series of business rules over time. And again, as I was mentioning before, the joy of this is they can change some of these business rules without having to go and change anything else. So they've since going live, they've actually made quite a few changes. Some of the changes, because we've taken this microservices approach, they can make some changes in here that mean none of what we've got on here is changed whatsoever. Other things here, they might decide that there's a small change in legislation that means they've got to account for that. Again, we can account for that within rules quite simply without having to change the whole thing. So it's quite a different approach to microservices. So, I mean, quite often when you hear at a Red Hat event people talking about microservices, it's quite often in a Java context. It might be something like microprofile. It might be something like Drop Wizard or Spring Boot. These are all perfectly fine technologies, but to develop a microservice-based approach, you don't just need to write Java or JavaScript in the Node.js world. You can actually mix and match where a rule itself could become a microservice, which is a good segue. So, for example, I could write a business rule using the Rules language, and I could call that via the RESTful API, and that could be a microservice in and of itself. So we've developed some examples recently where we've developed some user interface using the Nintendo digital experience platform, where the user interface is not hard-coded. It's all dynamic based on business rules. So if the business, using the example I mentioned previously that has the monolithic JavaScript application wants to change a business rule, what is presented in the web layer never changes because the UI is being built dynamically based on business rules. So based on my response to question 1, the rule says, okay, well, this is the question you should ask next. And based on my response to question 2, then the business rule come back and said, this is the question you should ask next. So this is something that the client finds particularly attractive because maintainability means, 10 minutes change, 15 minutes change, no need to redeploy the front end, no downtime. We can also use the DMN notation, decision model notation, which is published by the Object Management Group, the same organization that publishes the BPMN standard. And this is a bit more graphical way, whereas Rules is a bit more developer-oriented, DMN is something the business analyst can learn. And I'll come back to that point in a minute. And even though this is more about processes and rules, this presentation, I'd be remiss if I didn't mention that the whole continuous delivery, DevOps, auto-scaling type components are vital to being able to rapidly deliver these changes. So it's not just the architecture and the approach, it's definitely about the DevOps, the continuous delivery. And to my mind, that basically is OpenShift. So we've deployed some of these technologies in environments other than OpenShift, but we certainly noticed that in the OpenShift world, the time we take to deploy these things is vastly shorter. We've got our CI/CD pipelines, etc. So in terms of the technology stack, I mentioned earlier on that we were the first organization that would become partners with not just Red Hat, but Nintendo and Tricitech as well. So Tricitech is a modeling tool. So we can use Tricitech to develop business process model and notation, decision model and notation, and case management model and notation models that are largely graphical. So what we did with the insurance, the government insurer we mentioned before, that a lot of the models were developed initially by business analysts who would then sit with a developer and they might refine the model. But what the requirements specified by the analyst were often pretty much close to what was executed. So in some cases, we've got developers writing code. There's no getting around that in some cases. Zero code approaches tend to be rather limiting. So once we've developed our business models, we can then put them into the Red Hat Process Automation Manager or Decision Manager where they can be executed. Then we can create a UI using Nintendo. Now, I want to reiterate the point here that we're not building 20 process models and then implementing 20. It's implement one process model, implement a few rules, implement a few microservices, work with the developer to put it in the Red Hat stack, then go back and develop the next process instead of business rules. So we're very iterative, not just in an agile way of development, but very iterative in the CI/CD way of being able to deploy these things independently. So some key principles that I want to just finish on is what we're thinking about every time we do one of these type of engagements. When we're thinking about how can we use these to rapidly develop, what are the things we need to think about to make sure we're not just doing it rapidly but doing it well? So superior UX. So if you buy a packaged application, you're largely stuck with their UX. So some have better than others, but you're not going to be able to, in many cases, have your own CSS or your own HTML5 code or your own JavaScript. You're largely stuck with what the vendor gives you. So what we like about Nintendo is that because it supports, say, HTML5, CSS, any JavaScript framework you can think of, like, for argument's sake, React from Facebook. Anything you can build as a website, we can build as a Nintendo app that then pre-integrates into the Process Automation Manager. It also means, both at the front and back end, we have superior flexibility because we're not trying to create an SAP or a ServiceNow or an Oracle business. Generally, we're attacking smaller problems. We don't have to worry then about the limitations. We're just focused on the absolute flexibility to solve these smaller problems. And the non-monolithic bit is just so important because the ability to make changes moving forward means that we're taking that much effort, not that much effort. We're not having to worry about regression testing a 5 million line COBOL program. And even though I know my boss doesn't like the phrase citizen developers, it is something that comes up from time to time. And I do think the idea of citizen developers is a little bit overblown, frankly, but what we're really saying here is that the gap between the business, especially the business analysts, and the developers is lessened because we're using Trisotech to model these business models that are understandable by business people. And then often those business models, especially with the CMMN and the DMN, they're often just executed as they were modeled. And it typically is the BPMN, where the developer will say, okay, well, you've got a task here, we're sending it to that person to type into ServiceNow. Why don't we just send it to the ServiceNow API? So it's mostly in the BPMN that we end up making the changes. And the other point I can't leave without making is that every time we talk about this to a CIO, the question they ask, whether it's at the beginning or the end, is it cloud native? Almost every CIO I've spoken to in the last 6 months has said, I don't want any more tin in my data center. Or rather, I don't want any tin in my data center. So whether it's Azure, Google Cloud Platform, AWS, the question always comes, is this cloud native? And yes, it's all cloud native. As I said before, most of what we do with this deployment-wise is OpenShift, and most of that is cloud. So that's me for today. I think I've almost timed this perfectly. Thank you for your kind attention. I'll be at the Leonardo stand for a little while if anyone has any questions or objections. But thank you all.